let's see how much of it you remember. We start out talking about what a function is. Do you guys know the difference between a function and a relation? A relation is just any set of ordered pairs, any kind of correspondence. But a function is a specific type. If something is a function, then your x never gets repeated. So that is the first thing on your notes. Relation is just any kind of relationship between two sets. We're used to thinking of ordered pairs, but it could be anything. Your x is your input, your y is your output. Okay, specifically talking about a function, each input only has one output. If I plug in 5, I only get one answer out. I don't get 3 or 4. Okay, if it's a function, you do something to it, you get out one answer. We call the x the domain and the y the range in that. So, looking at this picture, is this a function or a relation? It will be a function. My inputs are my x's. Do you ever put in an x and get out 2 different answers? No. Each of my x's only goes to one thing, so that makes it a function. So my domain would be 1, 2, 3, 4. My range, the only y's that got used were 1, 7, and 4. So that's the first thing we're going to do is just look at tables, sets of ordered pairs, graphs, decide if it's a function, give domains and ranges from that. So this, my domain, that's my x's. You could just list them. You can list those in any order. All right. What if I gave you a table of values? So I have a couple of these. I want to decide if it's a function and then give domain and range. So is this one a function? Yes. What's your domain? Your inputs are your domains. Your range would be, if you have the same output twice, you still only list it once in your range. And if it's a function, it's okay for the y's to repeat, but not the x's. So the second one, is this a function? And this is not a function because the 1 repeats. We have the same input, but I get out 2 different answers. I put in a 1 one time, I got 3, and the next time I got 4, so it's not a function. All right, let's look at sets of ordered pairs and decide. So function or not, domain and range. Is this first one a function? Yes, if I look at all my x's, they're all different, so this is a function. What's my domain? Just all the x values of those ordered pairs. And the range? B. Function or not? Look at my x's, 1, 2, 3, 6. They don't repeat, so it is a function. The domain would be those x's. My range is my y's. 4 shows up twice, we only list it once, so it's just 4, 5, and 2. All right, C? No, because I see the -3 repeats. I give you a table or a set of ordered pairs, we're good. What if I give you an equation? Okay, so if it's a function, that means if you plug in an x, you only get one answer out. So if you give me a number, I take it times 2 and subtract 5. Will I ever get more than one answer? No. So this one is a function. Okay, my domain. You're going to pick a number and take it times 2. Is there any number in the world that I cannot take times 2? No, I can plug in anything I want. So instead of all real numbers, using interval notation, we will write negative infinity to positive infinity. We can plug in anything. Okay, range is your y's. That's what you get out. Would it be possible to get a negative answer here? Yeah. Would it be possible to get 0? Yes. Would it be possible to get a positive answer? Yes. So we can get everything here. So our range is also negative infinity to infinity. What about b? Is that one a function? A couple of you are shaking your heads no. Give me an x value. Pick a number. What do you want x to be? I heard 2, I heard 3, it doesn't matter. So if I plug in a 3, so I have 2x plus y squared equals 1. Okay. Is this one going to have a solution? No, it's going to be imaginary. Alright, so we tried plugging in a number. That one didn't work because it's imaginary. What if let's say I plugged in 0 for my y. You could put it in for you. 0 squared is 0. And so my x is plus and minus 1. Okay. What if my x had been 0? What would my y have been? Plus or minus 1. So I've already gotten 4 points on this. If you graph that, you might be able to kind of know what your graph is looking like. When my y is 0, x is positive 1 and negative 1. So 1, 0 and negative 1, 0. When x is 0, I got a positive 1 and negative 1. Do you guys know what this graph is going to be? It's actually a circle. Is that a function? No. Do you guys remember how to tell from a graph if it's a function? The vertical line test. I have that a couple slides ahead, but it kind of came up now, so I'm going to go ahead and mention it. If it fails the vertical line test, if you graph it, and you can draw a vertical line that hits your graph more than once, then it's not a function. So from that vertical line test, I know this is not a function. Another way I could know that is by looking at my ordered pairs. If my x is 0, I get both 1 and negative. So I put in one x value and I got 2 different y's out. So I can know it's not a function. So a couple different ways. You can think about it from tables of values, but people typically prefer the graph, which is why I kind of got enough points for us to look at that graph. So we're kind of leading into this graph discussion now. First thing I want to talk about is if I give you a graph, can we find the domain and range from that? So the first one, I don't know if you can tell from your paper, it's actually just 4 points. So my domain, what 4 x values do I use? the x value for each point, so -2, -1, 1, and 4. The range would be your y's. You can put them in any order. So the y values of these points would be -3, -2, +3, and +4. Okay, let's talk about the circle here. And everybody needs to pay attention on this. When you have a graph like this, think about domain goes left to right. It's like traveling along the axis. Range is talking about y, so you go bottom to top. Okay, so if I'm coming along for my domain, what is the very first x value we hit? -1. Then I'm hitting everything in between there. We're hitting all these x values, and it stops at 5. So my domain, interval notation, it does hit both the -1 and the 5, so they get brackets. So it looks like that. Range is referring to your y's. So as I'm going from the bottom, the first y value we hit is -4, and then the last y value we hit is 2. Okay, interval notation, you always have to go small to large. Alright. Let's talk about this one. And this is just a line, keeps going both directions. So my domain, if I'm going left to right, this keeps going to the left forever. Alright, that one keeps going to the right, so we get all of them. Your range, going from the bottom to the top, this is going down forever, so that's -infinity. That end is going up forever, so we hit everything from -infinity to positive. And one more piece, D, assume that has arrows, it's going to keep going. So a parabola, as it goes up, it's just going to keep spreading out. So eventually it will be going on in both directions. So your domain would be your range. I'm coming from the bottom. The first y value I hit is here, and then it goes up forever. So it's starting at 0. We hit the 0, so it gets a bracket. Goes up forever, so 0 to infinity. Do you guys remember doing this last year? So let's talk about, if I don't give you graphs, finding domains. In general, we assume our domain to be everything that would give us a real number. Okay, there are a couple specific things we need to worry about when we have a domain. We know that if you have a fraction, what can't happen? Okay, so in a fraction, the denominator cannot be 0. The second scenario we have to worry about is for an even radical. So I'm talking about like a square root, a fourth root, a sixth root, and so on. What has to be true on those if we don't want imaginaries? It doesn't have to be. If we want a pretty answer, it does. Right, has to be positive. Has to be whatever is underneath, we call that the radicand. Has to be greater than or equal to 0. Okay. So what I want you to do now The next slide I was just talking about the vertical line test, but that's already came up and we already said we know what that means. You remember it's a function, every vertical line can only hit it at most once. So I want you to go to this slide and take a second and decide which of these things are functions. Yeah, no matter where you draw that vertical line, it only hits once. What about the second one? Third one? Okay, this one, it's not turning into a vertical line, it looks like it, it's just slowly increasing, so it is a function. All right, are we good with the function, not a function? So let's go back. We've already done some where you had to decide from the equation if it was a function. Let's do some more of those. So this is one that we already did. And we already just kind of reasoned through it and decided it was a function. But now, knowing what we know about the vertical line test, what's another way we could decide? Could we graph it? Okay, grab your graphing calculator. So go to your y equals, and we have 2x minus 5. So what's this a graph of? Probably didn't need a calculator to graph this one, right? We know it's a line. Y-intercept is -5, slope is 2. You get a graph that looks something like this. So we can see that passes a vertical line test. It's a function. What would our domain of range be? Right, both of them keep going both directions. So we have negative infinity to positive infinity. Okay, you guys do B. Decide if it's a function, give me the domain of range. So, what's this graph look like? So, it is a function. Domain, it keeps going both left and the right, so negative infinity to positive infinity. The range, if I'm looking at my y's, the lowest y value we hit is 3, and then it goes up forever. So the range would be 3 to infinity. All right, this one. In order to be able to graph it on the calculator, you have to be able to get it to be y equals. That's not really possible here, is it? How can you graph things if you can't plug it in the calculator? What else could you do? In fact, like the very first time you ever graphed things, you made a table of values, right? Could we do that to get a graph? Would it be easier to plug in numbers for the x or the y? I'm going to do the y, so maybe I'm going to put in just a few. If I put in a -1, the absolute value of -1 is 1. If I put in a 0, absolute value of 0 is, if I put in a 1, absolute value of 1 is, so if I plot 1, -1, 0, 0, 1, 1, what is this graph going to look like? It's like a V, but it's kind of flipped on its side. You could always put in more if you weren't sure. You know, if my y was +2, we get out 2. If y is -2, we get out 2. So it's just going to look like this. So is that a function? I could technically still do domain and range. What is the domain of this? If I go from left to right, the first x value I hit is 0, and it keeps going forever. So 0 to infinity. My range, I have one piece going down forever and one going up forever, so that would be everything. Negative infinity to positive infinity. D. What if I had said y equals negative x? What would that be? Y equals negative x, that's just, we have a graphing calculator. But it's just a line. Y-intercept is 0, the slope is negative. It's just a slanted line like this. When you have inequalities, what's that do to our line? What do we have to add in our graph? I'm talking about everything greater than this. Do you guys remember shading? We haven't done that yet this year, and eventually we will, but not yet. What you really need to remember right now, if there's an inequality, it's going to be shading, so is it going to be a function? No, it's not possible, not a function, ever, if we have that. And with that line, we know any line, as long as it's not horizontal or vertical, our domain and range is everything. I would like for you guys to use your graphs and see if you can do E and F. So, first one we graph. Kind of like this. Is that going to be a function? It's kind of hard to tell what's going on. There's actually an asymptote right here. It's just a line we're getting close to without touching. But it's still increasing, it's still changing. So it is a function. That line doesn't actually turn vertical, it's still a function. Domain, you might be able to tell from your graph, or you could tell from this equation. What's the one thing x can't be? -2. So it's everything smaller than -2 and everything bigger than -2. Okay, the range. If I look at this graph, this piece is going down forever, so we're going to negative infinity. That piece is going up forever, but where's the piece where we break? What's the one thing we're not hitting? The x was -2. Think horizontally. 0. Will you ever do 3 divided by a number and get 0 for an answer? No. So my range is everything but 0. These are all types of graphs that we will look at later in the semester, but we're just kind of starting to get a feel for looking at a graph and kind of picking out domains and ranges. F, this one looks something like this, so is it a function? Yeah. Domain. You could maybe get it from the graph. You also know, I already told you that if you have an even radical, the thing under the radical has to be greater than or equal to 0. So your x has to be bigger than -1/4. So our domain is -1/4 to infinity. The range, what y values are we hitting? Everything starting at 0 and going up. So 0. Okay, I want to talk about just a little bit more and then we're going to stop for today. So we have talked all about what things are functions. The last piece I want to talk about today is function notation. So you guys have seen this before. Remember that f of x represents function notation. So f of x is like the y value. And it's just a convenient way of writing our equations so that we can easily plug in things. So for instance, if I said f of x is this function, and I asked you to find f of -3, what am I asking you to do? Plug in -3 for your x's. So I have the opposite of -3 squared minus 6 times -3 plus 4. So I get the opposite of 9 plus 18 plus 4. If I ask you to find f of r, what do I want you to do? Go to f and plug in an r for all of your x's. It's just negative r squared minus 6r plus 4. Last one, g of r plus 2. So the g tells me that I'm putting it into equation g, r plus 2. So I am replacing my x with r plus 2. What's it? Oh, we're doing g. So we can distribute, so we get 3r plus 6 plus 1, or 3r plus 7. So the last slide I want to do, I'd like you guys to take a second and see if you can do this one on your own, and then we'll talk about it. So I gave you 4 different ways you might see a function represented. Equations, ordered pairs, mapping, graph. I want you to find f of -1 on each. So you guys are good with plugging it into the equation. -1 squared is 1. You have 2 times 1 minus 9. And you get -7. When I say find f of -1, that means find y when x is -1. So if I look at these ordered pairs, here is when x is -1. What's the y? 6. Okay, if I look at this mapping, here's when x is -1. What's your y? 5. If I look at the graph, when x is -1, there's your point, so the y is 1/2. Okay, so tomorrow we are just going to do a little more practice with function notation, and we're going to talk about increasing and decreasing. So we've pretty much covered everything. The assignment, it's printed on the last slide of this. So just to recap, when I say EOE, what does that mean? Yeah, so it's like 4, you skip 6, do 8, 12, so forth. So it's 4, 8, and 12. These 18 through 20 is all, 26 through 66, every other even, 74 through 84 even. So pay close attention to that. Tomorrow, we've got some time right now, but it won't take me as long to get through tomorrow's portion of the notes, and so when I'm done, you'll have more class time to work on this. So this is not doing